Happy day students. Academy Pallikaranai Class-VII Mathematics Chapter 18 Reflection and Rotational Symmetry. So in chapter 18 we have reflection and rotational symmetry. So this is a short chapter only, if you are saying, means because we don't have many exercise in this. Okay, so just we can understand the concept what exactly the symmetry is and how to do the reflection and rotational symmetry. Okay, yes. And do you have any idea about what symmetry is all about? Because why I'm asking is you have learnt about symmetry in your previous 6th grade itself. So that's what I'm asking you. Do you have any idea about that? Okay, so I hope you all having a rough idea in the symmetry, and I hope you understood. You have understood why do we have these pictures on the screen, right? Because see, this is the introduction of symmetry. If a straight line passing through, in the middle of a picture, what do you observe? Children, tell me, what do you observe if the straight line is passing through in the middle of the picture? Because see, all that you see left hand side, all that you see in the left hand side, and all that you see in the right hand side. So this is the left hand side, this is the right hand side. So all that you are seeing in the left hand side and all that you are seeing in the right hand side, they are exactly identical to each other, right? So if you are, whatever things you are seeing in the left hand side and whatever things you are seeing in the right hand side, it is exactly each other, right? So that we are saying it is a symmetry. So like that, for here one star is there. So a straight line, it's cut exactly each other too. So see here, so both left hand side and right hand side, all that you are seeing the things, it is exactly each other. So that we are saying it's the symmetry. So I just recall you what is the symmetry is. Okay children, a figure is said to be a symmetrical about a line L if it is identical on either side of L, in case L is called the length line or axis of a symmetry. We can say the another name also, axis of symmetry also. And in the next thing, so in the next slide is, so what do we have and the next thing is, why do we have a monuments? That because all these pictures has around us a symmetry. So why we having here monuments? We know that these are all the monuments, right? These two are the monuments. That because all these pictures have around us the symmetry. Because if we are dividing, if you draw the straight line passing through in the middle of a Taj Mahal, we know that this is a Taj Mahal. If the straight line passing through in the Taj Mahal means, so the both the sides is exactly identical to each other, right? If you are seeing the left hand side, right hand side, it is exactly each other, it is exactly identical to each other. So like that, here also, if a straight line passes through in the middle of this picture means, so it is exactly each other. So that only we are saying this is a symmetry. So that we are saying this is a symmetry. Children, I hope you understood the symmetry what exactly is, right? Because you already learned the symmetry in your previous class. Yes. So let us make a symmetry. So how to making a symmetry, that we are see. Listen, and this is a paper. This is a chart paper or a A4 paper, whatever it is. So this is a rectangle size chart paper. If we are folding the rectangle shape chart paper, if you are folding this rectangle paper chart paper, so it is covered each other. Both the sides will be identical to each other, right? If you are folding into the half means, so both the sides will be equal, right? So and we are putting some colors too in the left hand side. If we are putting some colors into the left hand side means, again we can fold it the paper, so we'll get the symmetry. Why we are getting the symmetry? Because in the left hand side, whatever it is, see here, so in the left hand side whatever shapes is there, so it is passes through into the right hand side also. So that we are saying it's a symmetry. So as you see here, this paper is divided into two equal parts. Then in the left hand side, we pour some colors into the left hand side. Again we are closing the chart paper, and whatever it is in the left hand side, it passes through into the right hand side also. Okay, so we are getting the symmetry. And the next slide, yes. So symmetry we have already learnt in the previous grade itself, I told you. So this is reflection symmetry. This is reflection of symmetry, because in reflection of symmetry somehow we didn't learn in 6th grade. So I'll just telling you what is reflection of symmetry. Okay, so see here, one boy is standing in front of the mirror. Yes or right? Yes, right? So reflection, we all like to stand in front of the mirror. Yes, right? We all like to stand in front of the mirror, right? So we all can see our own image in the mirror. Yes, we all can see the own image. So whatever we are hanging in our hands, whatever we are tying into our hands, so whatever it is, whatever we are having, that will be shows in the mirror. So we all can see our own image in the mirror. But have you noticed one thing, that when you stand in the mirror, anybody notice? Have you noticed any one thing, that you standing in the mirror? You and your image are always will same distance. You and your image will always the same distance. See here, this distance will be same. This hand distance will be same, and this will be a same. Okay, so this distance will be same and this distance will be same. Okay, so you and your image are always will the same distance from the surface of the mirror. So this is called the mirror image. So we are saying this is called the mirror image. So see here, in this original image, the boy is standing, no? So in this original image, he raised his right hand side. He raised his little as a right hand. But if you are observing in the mirror, it is showing like in the his left hand is raising. Yes or no? See, in the original image he is raising his right hand, but in a mirror image if you are seeing, it is looking like his right hand is raising. Yes or no? So this is called a mirror image. Okay children, so this is the reflection of a symmetry. So we have many examples in the upcoming slides. Yes, see here, and we don't know what is the word of this one, but if you are seeing in the mirror, it will reflect the reflection name. So whatever things we are showing in front of the mirror, it will reflect. That is called a reflection. So whatever things if we are showing to the mirror, it is reflect whatever things we are having, that is called a reflection. Okay, and see here, this is a mountain. So this is also a reflection. So the reflecting the mountain on the water. And see here, this is a half of the butterfly. So the half of the butterfly we have to draw, but without drawing we can keep one like a mirror and we can observe what is the remaining half of the butterfly. So this is a mirror image. Yes, see here, this is a duck. So the duck is swimming on the water. See here, it is this is the mirror image, and this we can say it's a symmetry also. Yes, so this is the reflection of the duck. So this is the reflection of the duck. Yes, okay. And in the next slide, yes, next slide also. So I told you that I have collected many. So see here, this is also one monument. So the reflected whatever the buildings are there, it's reflected same as in the water also. This is called a reflection. And the butterfly, we can say this is a reflection as well as the lines of symmetry also. The butterfly I'm showing here, this will be a reflection or in the lines of symmetry also. So if we draw the straight line passes through in the middle of the butterfly, means we'll get the same. Yes, we'll get the same thing. It's exactly each other. It's exactly identical to each other. And here pot also there, it's also exactly identical. And here it is one human being face is there. This is also exactly identical to each other. Next slide. Yes, and next thing, it's very important. We want to know what are all the alphabets having a lines of symmetry. What are all the alphabetics does not have the lines of symmetry. As you see here, A is the one lines of symmetry, because only one line it is crossed out the A, and B also. So we don't draw like this, because if we are drawing like this means the both the sides it is not exactly each other. So we cannot draw like that. And A, B, C, D, E, F. What about the F? Why there is no lines of symmetry? Because if we drawn in a horizontal line symmetry and a vertical line symmetry, so they have not exactly each other, so they have not exactly coincidence each other, so the F is a no lines of symmetry, as well as the G also no lines of symmetry, the J also no lines of symmetry, the L also no lines of symmetry. See here, the L, if I drawn like this means, so this side and this side will be in a different, so we cannot draw the lines of symmetry. So this is the thing. And here this X is the two lines of symmetry. So if we drawn like this means this side will be equal. If we drawn like this means this will be equal. So we can say X is a two lines of symmetry, as well as O is a two lines of symmetry, as well as H is the two lines of symmetry, I is the two lines of symmetry. Yes, that's it. So these are all the two lines of symmetry, and the remaining is the one line of symmetry, and some letters having no lines of symmetry also. And coming to the next slide. Yes, this is very important. So in the shapes also we have a lines of symmetry. In the shapes also we have a lines of symmetry. So as you see here, a rectangle has two lines of symmetry. A rectangle has two lines of symmetry, each one of which is the line joining the midpoints of opposite sides. Line joining the midpoints of opposites of sides. Okay, as you see here, the square having four lines of symmetry because the diagonals also it is crossed together. So that only we are saying a square has four lines of symmetry, namely the diagonals and the lines joining midpoints of its opposite sides. And here isosceles triangle in the sense, we know that isosceles means two sides will be equal, so that only it is one lines of symmetry, isosceles triangle. Okay, and it is a regular pentagon, regular hexagon. So these are all the some lines of symmetry. So see here, and the final one is equilateral triangle. So equilateral means that is three lines of a symmetry, and equilateral triangle is a symmetrical about each one of the bisect at intersects angle, interior angle. So that we are saying that is three lines of symmetry. I hope you understood the lines of symmetry. And let us coming to the rotational symmetry. And the rotational symmetry also, it is very important. And if we rotate also, how many orders of the rotational symmetry? Okay, first of all, I'll tell you what is rotational symmetry. A figure is said to be having rotational symmetry if it's fit onto itself more than once during one's completion. So we know that the complete rotation means from 0 to 360. That is order of rotational symmetry. We know that 0 to 360, which is one complete rotation. If we are rotating from 0 to 90 degree, 90 to 180 degree, 180 to 270 degree, again 270 to 360 degree. So this is one complete rotation. Okay, so using that we can see some examples. Yes, so this is a B. This is the original shape. If I'm rotating the shape into 90 degree, so you can imagine this is the midpoint of the shape. So this will be rotate into the 90 degree means, so this is 90 degree. Again I'm rotating the 90 degree plus 90 degree, that is 180 degree. If I'm rotating means, so we'll get the image like this. So this is not exactly each other to the original shape. And coming to draw the another 180 plus 90, that is 270 degree. So again it is rotating like this. So we can get this image. So it is not exactly identical to each other. And again 270 plus 90, it's a 360. So if we are taking it as a 360 means we'll get the original image. So only one order of rotational symmetry we have in this B. Because if we are turning into 90, we will get not a original image. If we are turning into a 180, we didn't get a original image. If we are turning into 270, we didn't get original image. And if we turned into 380, we got the original image. So this is the order of rotation. So we have to turn the image into order of rotation: 90, 180, 270, 360. This is one complete rotation. Okay, and yes, so I have given some letters here. Here it is H is there. Okay, so H, we need to find how many order of rotation. The H is how many order of rotation. So first of all, I'm turning into 90 degree. If I'm turning into 90 degree means it will become like this. And if I'm turning into 180 means it will become like this. Now it is exactly identical to the original. And it is 180, and 270 means it is like this. And 360 means it is like this. So this also 1 second. Yes, this is a 180. This is 90 degree, this is 90 degree, 180 degree, 270 degree, and if it is a 360 means again it's a same original page, it's a original picture. So the H is a order of rotation is 2. The H rotational symmetry of order is 2, since each one of this letter have been rotated through 180 and 360. So if we rotated in 180, it will be identical to the original shape. If I rotated to the 360, it will be identical to the original shape. Yes, are you clear children, this H? Okay, and coming to the X. So X, if you are rotating means it will become like this. Yes, and if I am rotating like this means, so this will be equal to this. And if I am rotating in the third one, that is 270 means again the same thing like this. And if I am rotating in the 360 means again the same thing to the original. So X also, it's a 2 times of order of rotation. And A. So A is like this, and the second 90 degree means it is like this, and 180 means it is like this, and 360 means 270 means it is like this, and 360 means it is in the original shape. So only A is the one order of rotation. So I hope you all understood the order of rotation. So let us move to the some shapes. So previously I have explained you using the using the alphabetic letters. Now I will show you the diagram. Okay, so as you see the original picture here, it is a rectangle. So the rectangle is rotated into 90 degree. So 90 degree means it will become like this, and again it is rotating to the 180 degree. So the 180, it is equal to the original shape, and again it is showing to the 270, it is not equal to the original shape. Again it is rotating to the original 360 degree, which is equal to the original shape. So order of rotational symmetry is a 2. Okay. Yes, and children, I hope you all understood the concepts of rotational symmetry and the reflection symmetry as well as the symmetry, because you all know what is symmetry already. Okay, and then just I want to give you the so thank you children. So we can see in the next chapter video. Thank you so much. I hope you understood the rotational and reflection symmetry. So thank you children. Thank you once again.